All right, welcome back to Algebra 2, Semester 2 lessons with Mr. Who. We're going to talk about Skill 11, which is simplifying radicals today. So something hopefully is a little simpler, a little on the lighter side for procedure as far as that's concerned. And so here's all we have to talk about today. All right, there are a couple of radical rules, and by the way, a radical is this bar, this funky looking square root sign. Okay, but it doesn't apply to just square roots. It applies to just anything that is with an index, but usually it's squares, right? With 2, index 2. But you've also probably seen index 3, maybe some index 4, index 5 stuff. Okay, so there are the parts of the radical. You can look at those. Okay, but what we're going to talk about today, okay, the types of problems we're going to talk about are root of a product, okay, specifically this rule here. Okay, we're also going to talk about this fractional exponent idea. We're not going to really focus on this root of a quotient idea too much. That is not super like intuitive on the delta math, so we decided to leave that out. Okay, but these two are definitely more important, and I'm going to choose to focus on those today. All right, so here are the steps to simplifying your radical. Okay, step 1, you have to identify the root or index. Okay, so that would be this part in blue. Okay, that part in blue tells you what you are rooting. Okay, so if it doesn't appear, you can assume it is square root. Okay? But if it does appear, it's either a 3, a 4, or something higher than that, and you have to pay attention to that number because that is what we're rooting by. Okay? Cube root, fourth root, okay? However much root you have. Okay? I'll be looking at these down in the examples below here, as well as a bit on delta math. Okay, so if you're not sure what exactly that means, okay, I'll be able to label that for you in a second. Step 2 is to break the radicand into prime or simplest parts. So this would just be factoring kind of your inside, your radicand here in the red. It's not always just going to be x, right? Could be made of multiple things like you see in these examples down here. But you're basically going to split it up, okay, especially numbers. So I'll be doing that mostly with numbers. With variables, it's kind of going to be a little easier. So watch that for that in the examples. Step 3 is to group similar, prime, or simplest part by root index. Okay, so that would be when we actually do split apart the factorization of our numbers. Okay, we have to organize it so that it fits our root. Okay, and then if we form a group according to our index, okay, then we can move it outside after applying the root. Okay, so again, I'll see that with the examples. And finally, if there was a denominator anyway, you would rationalize it, but we're not going to deal with that today. So we're going to just go kind of ignore step 4 here. Okay. So let's move on to the examples. All right, let me clear my circles here. Okay, so I got 6 examples here that I'm going to, well, 4 examples I'm going to do here, and then I'm going to go to delta math and do a couple on there. Okay, but let's go ahead and start. So this first one is the square root of 4x to the 6th. Okay, so step 1 would be identify the root or index, which I don't see any, which means I'm talking about a square root. Okay, square root here. This is the easiest one to talk about. It's that nice button on your calculator as well. Okay, but I'm talking about squares. So I'm talking about perfect squares. Next, I'm going to break down the insides. Okay, so I have a 4, okay, 4x, and this x is the 6th. Okay, so this is like my square root of 4 and my square root of x to the 6th. Let me actually move my x to the 6th to be a little more inside the square root sign. Okay, so okay. This is according to that first rule in the radical rules up top when I started the lesson, okay, the one I circled first. So please go back and review that if you've forgotten. Okay, then I just simply carry out the square root sign as it is. Okay, so what number times itself would give me 4? Hopefully you answered 2. Okay, so I have a 2 right there. And then what number squared multiplied by itself would give me x to the 6th? Well, it's not really that apparent so far because, well, it's not x squared, right? So it's going to be a little hard to do that, as you might think. But actually, I can split this into, if you remember your exponent rules, x to the 3rd times x to the 3rd, right? That's a very bad 3, but there you go. X to the 3rd times x to the 3rd. Because of that, okay, I can say, well, x to the 3rd times itself is x to the 6th. So I can just kind of cancel that out, okay, with one of my x to the 3rds because that's the squared root process. And so my answer, I'm going to use a different color here, would be 2x to the 3rd. No radical included. Okay. So we'll talk about it later, okay? But when we're talking about variables, usually you're just going to divide the exponent by the index. With our index of 2, I have 6 as my exponent, divided by 2, I have 3. So 2x third is my answer for the first example. All right. For the second example, I have an index of 3. I know it's a little hard to see, but it is index 3. So I'm talking about third root, okay, cube root. And if you were paying attention to what I just said, you should hear that, well, I have a to the third, okay, and b to the sixth inside, okay, my cube root. All I have to do is divide the exponent by my index, which my index was 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. Okay? So when I do that, I should be able to cancel them down with the third root, the cube root, to be a b squared. I should actually use green again. Sorry about that. So erase that to kind of showcase what the answers are here. A b squared. That's for example B. All right. So let's just keep applying this rule. Let's keep applying this rule that we kind of picked up to number C, letter C. I got a 4 as my index, so that's fourth root. Okay. And I got x to the fourth, y to the eighth, z squared on the inside. Of course, that means I want to divide the exponents by the root, okay, by the index. And so 4 divided by 4 is 1, so I have 1x here. Okay. I'm actually going to put out the answer real fast. I don't feel like I don't need any work. If you feel like you don't need any work, then you feel free to just go ahead and simplify it as easy as you can. 4 divided by 4 is 1, so x to the 1. Y to the eighth, 8 divided by 4 is 2. And z to the second is 2 divided by 4. It's actually not going to simplify all the way out. You can write it as 1/2. Okay. But, we seem to run into a problem with that last term, that last factor of z squared. I can't take it out 4 times, according to the index. In fact, I'll be left with less than power of 1. Okay. And here's where you can kind of use the backwards version of what we talked about with dividing the exponents by the radicals index, okay, where is an exponent 1 divided by index 2. So I can actually rewrite this as x y squared square root of z. That is because there would be a 1 power there and index 2 out here. So this could be my final simplified form. So sometimes you can leave the radical in there as long as you see a fractional exponent. And I think that is the way we prefer you to write it out. So on Delta Math, when we get there, I will probably show you a couple examples like this just to make sure really understand the idea of fractional exponents and how they work with our index. Okay. All right, last example here, I'm going to go ahead and switch back to black because this one does have some numbers, so I'm going to have to be a little careful. And it has a negative sign too, so even better, right? This is index of 3. Okay. Square cube root of negative 27 c to the 6th b. Okay, so let me take a look at the inside first. I got negative 27 as my number there. I got c to the 6th as my c's, and I got b just by itself. Okay. And I'm cube rooting all of those pieces. Okay. So when I take the cube root of negative 27, I note that it's a negative number. So something times itself 3 times. Something times itself 3 times will give me negative 27. Actually, this is going to become negative 3 cubed, okay? Negative 3 cubed, if you know your cube chart. Whereas this I can simplify to c squared cubed, okay, by taking out a 3 from the exponent. Okay, that's multiplication, right? And this one I can't really simplify at all, so this one's just going to be b as well. All right. So now I'm going to write with a green marker to indicate I'm finished working here. So cube root will cancel out this guy, right? So I'm just left with negative 3 on the outside. Cube root will cancel out this guy, so I'll be left with c squared. And cube root doesn't work with b at all, so I will leave it inside my index, my radical, okay, with the index 3. So here's my answer there. Alrighty. So that's it for the notes part here. I'll go ahead and go to Delta Math to show you what kind of modules you'll be working with here. Just kind of get your toes wet and give you a little more examples as far as the radicals are concerned. Okay, and I'm back with this module titled Simplify Nth Root Radicals Type 2. Okay, so this is a multiple choice module, so it should already be a little less stressful than you think. Okay, but what you might see differs a little bit from what you might be able to interpret. So this is an example with the expression sixth root of x to the seventh is equivalent to one of the following. Okay, so remember with this, okay, this is actually where the notes kind of will allow you to think about it a little more. But remember when I said you should group your insides based according to your index. Okay, well I'm going to go ahead and do that for you here so you just know how to handle that. Okay, this is probably the hardest this lesson will get. Okay, as far as that goes. The next module I will show after this is a little harder, but it will accept fractional exponents, so it won't be that bad. Okay, but for this one, I have an expression, okay, x to the 7th. Okay. It's inside an index of 6, which I'll put up here, index 6. Okay. And so what I'm thinking about is I want to have it so that my exponent can be divided by 6. Okay, so what I want to do is split my x to the 7th apart into two different factors, an x to the 6th, which has an exponent divisible by 6, and an x to the 1. Okay. So x to the 6th times x to the 1 should be x to the 7th, okay, according to our exponent rules. And so when I take the sixth root of both of these pieces, okay, I'll use a different color there. When I apply sixth root to these pieces, this first piece, these should just go away, right? Because 6x's, I have sixth root. Those should cancel. 6 divided by 6 is 1. So what I'm left with on the outside becomes just x. Well, on the inside, okay, which I can't divide, should be this sixth root of x. Okay. Out of these following answers, that definitely looks like this one right here. Okay. So remember, when you take it out, you do have to shed away that sixth part. So none of these other answers are really going to be the same. Except for maybe the first one. You might think the first one is similar, but exponents don't line up there. Let me go ahead and put this through. And ta-da, I'm covering it a little bit, sorry. But ta-da, there's the answer there. Divide by 6, the root. Okay. And they even have the work here to show you their steps. So if you ever get stuck on these guys, you can always give it a shot. Okay. Let me try another one of these, because they're going to be a little difficult. Okay. So wipe my board. Change my color back to black. And let's have another go at it, shall we? Okay, so 8 index. Okay, so I know we're working with high indexes here, but we're not going to have any numbers to deal with. Okay, that's the next module I'm going to talk about. For the purposes of the problems here, you won't see an index higher than 4 if you have numbers in your radical. But for variables, you can see however far you want because usually the rules are pretty solid. So x to the 35th, okay, at an 8th root. Okay, well, this time you might think, okay, I don't think 35 can be divided by 8, so that means we can rule out these guys right here because those divide cleanly, right? So let's just take a look. If you wanted to split your x to the 35th apart, you could do it such like x to the 32, x to the third. That definitely works. Okay. Remember, this is all to the 8th root. And so 32 divided by 8 should be x to the 4th. Let me change my color again here. And my, sorry, let's say 4. And my x to the third just stays inside. Okay. Which of those two answers down here looks the same? I believe it's that third one, top right. So let's click that, submit our answer, and bam. There we go. And just like it said, looks like they followed the same steps I did. So hopefully this is straightforward to you guys. That module shouldn't give you too much trouble. Let's have the last module for the notes. Okay, so here's the last module, the hardest one, I suppose you could say, that includes both numbers and variables, okay, both integers and variables in the problem, okay, but you'll never see higher than a fourth root here. It'll always be third, fourth, or second, okay. And so it will ask you again, which expression is equivalent to the following, okay. It'll ask you to simplify it, right? And so we kind of just do like we did in the notes video, where you just take your pieces, you got 27 as my number, my integer, got x to the 5th as my, actual x parts, and my y to the 8th as my y parts. And those are all being cube rooted. So index is 3. Okay. So that means that's what I'm going to divide the exponents by here in a sec. But remember from the video, 27 is actually 3 cubed, so I'm going to rewrite it 3 cubed. Okay. X to the 5th still is there, and y to the 8th is still there. You will notice that their answers are given with the fractional exponents. So this module, you'll be able to use fractional exponents. Okay, I would say normally on like standardized tests and stuff, you probably would want to use the pull out of the square root or cube root method, pull out of the radical to simplify. Don't want a fractional exponent, but at least for this one, you can totally use it. So let's divide all those things by 3. Okay. And so these would cancel out to be 1, which means our answer on the left is 3. Okay. So that means I'm automatically marking out this fourth and second option. X to the 5th divided by 3. Well, those don't really divide, so I'm just going to leave it 5 over 3. And then y to the 8th divided by 3. Well, those don't really go away either, so this would be my final answer as far as simplifying goes. Out of the two I see here, I think the first option fits my bill. So I'll click that one. Let's plop it in there. And we got it. So again, just take it easy, split apart your pieces, okay. Figure out what the number, cube root or fourth root or second root is, square root, I guess, is what that is. And it will show you here. So if you get stuck on this module, take a look at the video, okay? Or take a look at the examples given to you if you get it wrong a couple of times. But there it is. All right. I will see you all next time. It's getting pretty close to fall break, so I might not see you until after fall break, but I hope you enjoyed today's video lesson, and I will see you all next time.